Okay, in this problem, I've got a particle, it's in a straight line, acceleration as a function of position. Okay, I know that the velocity is 0 when s equals 0. Okay, I want to find the velocity when it equals 2 meters. Now notice time, oh, I also want to find the position when the velocity is at its maximum. Notice time is nowhere to be seen. Okay, so because of that, I'm not going to use any equation that has time in it. I'm going to definitely use my ADS equals VdV kinematic equation here. Again, knowing that A is 8 minus 2s ds and then v dv, like so. I'm going to integrate both sides. Okay, now again, v is 0 when s is 0, so these will both start at 0, and they'll both go up to an arbitrary variable, either s or d. So on the left side, I'm going to get 8s minus s squared, and again, this will go from 0 to s. On the right side, I'm going to get v squared over 2, and this will go from 0 to v. Now, plugging in 0, these all go to 0, so what I'm left with here is simply 8s minus s squared equals v squared all over 2. Okay, so now the question becomes, okay, what is the velocity when s equals 2? So I'm basically just going to take 2 and plug it in there and there. Okay, and from that, I can calculate that my velocity is going to be 4.9 meters per second. Just by plugging in s equals to 2 into my equation, I can figure out what my velocity will be. Now, what I want to do is I want to find basically at what position is the velocity the maximum. So what I'm going to do is I'm going to take this equation, I'm going to bring 2 over to the other side. So basically I'm going to say, okay, v squared equals 16s minus, I'm sorry, 2s squared. Okay, and what I'm going to do is I'm going to take the derivative and set it equal to 0. So I'm going to take the derivative of the left of v squared, okay, and I'm not going to solve for v, because if v squared is at its maximum, so is v. And the integral becomes a lot more tricky if I square root both sides, right? So I'm just going to leave this alone. I'm basically going to say, okay, when the derivative of v squared equals 0, then the maximum is at 0, right? So I'm going to take that derivative. That would be dv squared ds. So that the right side, take the derivative as a function of s, and I'm going to get 16 minus 4s. And what I'm going to do is I'm going to set that equal to 0, because that's how I find a maximum. I take the derivative and set it equal to 0. Again, I'm just doing it for v squared, because the maximum of v squared will also be the maximum of v. And from that, I can find that this maximum occurs at 4 meters. And I could find the maximum by plugging that 4 back into the equation and figure out what the v would be. But the problem's not asking for that, so I'll leave it alone at that. So again, notice time is nowhere to be seen. Okay, so because of that, I'm going to use the kinematic equation that does not involve time, and makes the equation not too bad to calculate.